Well, hello everyone. Welcome back to my YouTube channel and welcome to this video. Today we have a very amazing session. This video has two main parts, okay? The first part is dedicated to answer the question, why do we need hardware in the loop? What is hardware in the loop and why do we need them? And then we will answer that question because we will do a workaround on one very beautiful device, and that is the Typhoon HIL 604. Okay, and for that reason, please stay and watch this video. It will be extremely interesting. Um, something that is appearing quite frequently is the question: what is hardware in the loop? What is hardware in the loop in real life? And do we need to use hardware in the loop? Why do we need hardware in the loop? And real-time simulation, of course. Well, let me start this explanation in a very simple way, okay? Power system has been for more than 100 years producing, transporting, and delivering electricity to the customers, okay? In real life, power systems, they are physical systems. I mean, the power utility is a physical infrastructure where you can find real wind turbines, PV system, transmission lines using big towers, and nuclear power plants, and so on. Okay, what I'm telling you is that a power system is typically a physical system. Okay, you have physical, real components. Okay, but at the very beginning of the power system history, the power systems were very simple, and control systems are there in order to keep the power system running. At the very beginning, control system was very basic, using electromechanical components, using basic physics and mechanics. It was quite good, okay? However, as the technology evolved and also as the power system evolve, many change has happened in the power system. One of them is that we are pushing toward a low carbon society. Low carbon society require more variable and renewable generation coming from wind power and PV systems. Okay, and that start to impose several challenges in terms of operation and security and economics inside the power system. The good news is that at the time that the generation and technologies are evolving in power system, also in other areas are evolving, and that is in the cyber side. Okay, today the power system is a cyber physical system. What is the reason? Well, we have the traditional component, the physical component, the transmission line, the transformer, the loads, the electric cars, and so on. But remember, control systems are becoming more and more demanding, and we need computational power. And also, we have network communication networks to support all this infrastructure. To be honest, power systems are cyber physical systems because today the power system is combining the physical process, the networking, and the computation. What is the idea? That the power system operate at the best as they can, okay? That means more secure power system, more reliable power system, and a total cost reduction. Okay? When we look into the power system as a cyber physical system, we need to identify that they are real components like transformer, boosters, capacitors, generators, and feeder. And those devices, for instance, just talking about a very specific application, all those devices are located inside the substation. Okay, the substation is a very critical point inside the power system. Okay, there are many critical points, but the substation is one of them. They are very expensive equipment like the transformer, and also they are near to the customers, and as consequence is very important to have a secure installation. Okay, today the physical layer of all those devices, transformer, buses, capacitor, generator, feeders, they are collecting some real-time measurements and also receiving some control commands. Okay, in power system has increased and has growth in terms of size. today we are talking about interconnected continental Europe, for instance, one of the biggest power system, or what I'm trying to say is that the power system has substation in many places. At the end, one way to communicate or to move those signals coming from real-time measurements and control commands is using wide area network. The wide area network is the channel that is moving all those signals from the substation until the control center, where the SCADA system and the EMS is making some functions, okay? What I'm trying to say is, in real life, the power system is a cyber physical system, and particularly the substations are quite interesting and quite important because they are very critical components, okay? Going into the substation, I would like to show you something very interesting, okay? As you must be aware, I am interested on protection system at the moment, and I am really into the digital transformation at substation level. In a classical substation level, we have physical layer, and that's correspond with the real physical components. For instance, here you can see the single line diagram, and we have circuit breakers, we have transformer, we have feeders, and so on. That is green color over here. That is the physical layer. On top of that physical layer, now we have a cyber layer. That cyber layer is related with the new digital area of the substation. It's related with the station bus, with the process bus, and with the process level, okay? What I'm trying to say is, as in any power system, we have measurements, real-time measurements that we need to send to the control center, but also we have commands coming from the control center. As a consequence, we need to find an interface, a cyber physical interface, moving all those signals up and down to the cyber layer, and the cyber layer is where all this communication, all this computation take place, okay? Now, probably you are wondering, okay, why this gentleman is talking about digital substation? Well, digital substation because protection system become more and more complex. Today, every single relay, the ID has multiple functionalities, okay? And it's not just the functionality, it's that it's receiving, processing, and delivering information in real time. And that is where the hardware in the loop and the real-time simulation start to be part of that. What is hardware in the loop? Hardware in the loop is a technique, it's no new, okay? Hardware in the loop is no new, has been in the market for many years. It's a technique that has been used for many other industries. For instance, for the aerospace industry, for the vehicle industry, and so on, okay? Hardware in the loop has been developed has been create in order to develop and test complex real-time embedded system. And to be honest, hardware in the loop is the best way to test and develop this kind of real-time application, okay? Now, let me show you, let me explain a bit what is the hardware in the loop. The hardware in the loop can be very simple show here. One of the approach for hardware in the loop is presented below here. You have a host computer. That host computer can be used to control the real-time simulator. And the host computer typically run in one operating system, and there is a software over there that basically is creating the model, the digital model, for instance, of a real power system like the continental Europe, and then including that model, downloading that model into the real-time simulator, the target, okay? Now, the core of the real-time simulation, the core of this hardware in the loop is basically the real-time simulator. The real-time simulator is a computer with a lot of computational power. It's typically used using a FPGA, or there are other very powerful processing unit that can be used for the real-time simulator. But the real-time simulator have a processor that is running the computation, the calculations in a very fast way, okay? And inside this real-time simulator, we have the model, for instance, of the actual power system, okay? And inside this real-time simulator, we can run simulations that represent and behave like the real power system in real time, okay? Now, For instance, if we are running a simulation about a transient dynamics, we can have, for instance, the instantaneous value for voltages and currents. And those instantaneous voltages and instantaneous current can be used for test any kind of controller or any kind of protection. And that is where we have here our prototype or the subject on the test. Okay, if we are running a time domain simulation for a power system, we can use output signals that represent the three-phase voltages and the three-phase currents. Okay, and we can use those signals to test, for instance, a protective relay. In this sense, we are using real signals coming from a real power system, replicating the behavior and closing the loop in what we call the hardware in the loop. Hardware in the loop, we have here the real-time simulation, and we have over here a hardware, a prototype that is under test or developing, okay? One of the situation over here is that the prototype is closing the loop. We are talking about hardware in the loop, we are closing the loop, and there are some signals, input and output signal closing the door, closing the loop. To close the loop, typically we can talk about low power signals and high power signals. If you are testing or you are developing a real protection relay, for instance, distance protection, we need voltage signals and current signals. If you are using, for instance, the cell 411L, that is a differential protection for transmission line, you will need the voltages ABC with a maximum voltage of 300 volts. And if you are using this relay in Europe, you need current signals, three-phase current signals, and these current signals are in magnitude around 1 amp. What I'm trying to tell you is that if we are using a real hardware like a real relay coming from Schweitzer laboratories, we need voltages around 300 volts and 1 amps. What is true is that the real-time simulator has the possibility of producing low power signals. A typical real-time simulator has the possibility of producing signals of around 10 volts, positive and negative, and very low currents in the order of milliamps. For that reason, if you are running hardware in the loop using power components, you need what we call a power amplifier. The power amplifier is basically taking the signal, the digital signals coming from the real-time simulator and transforming into the analog or digital signal that you need in high power to apply for the device. For instance, if I am running a short circuit in the continental European power system, I will get currents like 1 amps that I need to put inside the relay in order to trip. In that sense, the power amplifier do that job, okay? Well, I need that you understand, and it's being clear for you that the hardware in the loop is the best technique in order to develop and test complex real-time embedded system. And complex embedded system, real-time embedded system are everywhere inside the power system. For instance, overcurrent protection. Our current protection is taking signal from currents. Then there is a program, a software that is taking decisions in real time if the current is representing a fault condition or not. What I'm trying to say is real-time embedded systems are everywhere inside the power system. And the power system is a cyber physical system making the replicating many of the conditions inside the power system very difficult, and the best way to replicate that behavior is using hardware in the loop. Okay, well, just for conclusion here, hardware in the loop is a technique. Hardware in the loop is used for test and develop complex real-time system. And everything is needed because we are working in modern power systems that they are cyber physical systems, okay? Well, now I will move to the very beautiful device that we need to talk today. We are talking about the Typhoon HIL 604. I am really proud and I am really happy to have this device here at my lab, okay? The HIL 604 is a product. Typhoon HIL is a company that has been many years in the market, developing real-time and hardware-in-the-loop solutions. They developed the Series 4 and the Series 6, and right now the top of the line on the Typhoon HIL development is the HIL 604. I am really proud and really happy to having this device at my lab. This is an extremely powerful device. In a minute, I will tell you about the technical details, but inside there are multiple cores in order to perform extremely fast calculation with a very accurate results. Also, this device is extremely easy to use, and because it's Python based, allow to test in a better and faster way your final product. Okay, this device is very compact, is beautiful to the view, and has a very powerful processor. Okay, I am really surprised about the number of inputs and outputs that this device is able to provide. The Typhoon HIL 604 has low power outputs, but these have many inputs and output, digital and analog, that you can use. And all the equipment is extremely compact, okay? I will go now to show you some of the details related with this device, okay? Inside this device, there are up to 8 cores, okay? That is to provide the computational power that you require to run real-time simulations. Real-time simulation where 1 second of calculations represent 1 second in real life. Regarding outputs and inputs, I am really surprised with the number of channels. This device has digital outputs, 64 channels, 64 channels for digital inputs and outputs. And for analog, this device has 64 analog outputs and 32 analog inputs. To be honest, these analog inputs, all of them has a resolution of 16 bits. And in the case of the analog inputs and outputs, they are able to receive plus and minus 10 volts, symmetrical plus 10 and minus 10. That is a very important feature, especially if you are working with AC signals in a dynamic process of a power system, okay? Regarding connectivity, wow. This device has several communication ports that even some of them I never used before, okay? In a minute, I will go to do the workaround on the device and I will show you, but this device has USB connectors, Ethernet connectors, CAN connector, RS232 connectors, and of course, PCIe, okay? Something that you will see in a minute, this is extremely beautiful and compact device. You will see that this is a 2 rack units. That is perfect for the rack mounting, and also is very light, it's only 10 kilograms. By the way, it's not so noisy and it's not annoying, okay? Finally, the software that is used with this hardware in the loop device is the HIL control center, okay? This video here is extremely short. The idea is that you have a taste about the device, and also my student can understand the basic functionalities and the basic specification, technical details of the device. If you want to learn more, please go to Typhoon HIL website, okay? They have a very well documented, it's excellent documentation that you can go there, okay? In my next videos, I will start to do more and more active with this device. In a few weeks, I will be releasing some videos about the HIL control center, that is the core, the software core for using this device and taking all the power of this hardware in the loop, okay? Well, what I will do now is I will go to the real device, okay? In a minute, you will see the real device that I have at the lab, but at the moment, what I need that you understand is this device has a front panel and a rear panel. The front panel look extremely
it's exquisite. It's simple but extremely useful. Okay, the front panel look really nice, very simple, but you have over there what you need to have. And the back panel, wow, is the rear panel is a full surprise because the device is equipped with so many communication protocols, but also include high-speed serial interface. Okay, um, in a minute I will go for every single of those ports and I will tell you a bit more. Okay, well, let's start with the workaround on the Typhoon HIL 604. Okay, and let's see the physical device. Here we have this beautiful device. This is the Typhoon HIL 604 that we have at the lab, okay? The first thing that you notice when you have this device in your hands is how solid and how beautiful is the finish touches that they made on this device. Is basically a solid, a robust device. The first thing that you must notice over here, you can see at the right at the middle, the elephant. As you must know, Typhoon HIL has a logo, and that logo is the elephant. In this case, we have the red color for the Typhoon HIL device. Okay, this is the logo. Over here on the left hand side, you can see HIL 604. That is the model of this beautiful device that we are talking about. As you can see, there are two handles over here because this is a two rack unit that is this by 19 inches. And as you can see, this kind of these two handles, they are extremely beautiful. I love this feature because allow me to put in my rack in a very easy and safe way. Okay, well, coming back to the main features of this device, we have here the model, the logo, and on the right hand, we have the power switch, okay? Here we can switch on and switch off. It's extremely simple when the device is on and of course properly connected to the power supply. You will see this LED white color fully turned on, and that means that the device is on. Okay, at this moment the device is not connected to any power supply. That is the reason that you don't see the LED on full turn on. Okay, one thing that surprised me is how simple but efficient is the front panel of this device. Okay, as you can see over here, there are four connectors. At the very beginning, when I saw those connectors, I was a bit scared, okay? Because those connectors, they have the analog and the digital output of this device, okay? On the left-hand side, you can see this is the digital inputs and outputs, and on the right-hand side, you can see the digital inputs and outputs, okay? We are talking about here of big connectors, okay? We are talking about that there are many pins over there, and I was scared at the very beginning. However, I realized that those black terminals over here, they are extremely helpful because at the end when you are connecting your device, there is a plug that you can put over here, making extremely easy the connection. And also there are two screw or four screw that you can use to fit the connector to these terminals. Okay, that is extremely helpful, extremely safe. Okay, in this case, as you can see in the front panel, is very simple, and you will find all the channels, the digital on the right hand side and the analog on the left side. Okay, well, now let's go to the rear and see the very important part related with the communication ports. And this is the rear view, the rear panel of this Typhoon HIL 604, okay? First thing that you must notice, the logo here, again, the red elephant. And on the right-hand side, you can find a sticker. That sticker is presenting to you the model. In this case, this is the HIL 604, the part number and serial number, okay? On the left hand side, you can see here, this is the connector where for the power plug. Okay, here we are providing the power supply for the real-time simulator for the HIL 604. And as you can see over here, this device is able to work in Europe and America, because this device is working on 50 hertz or 60 hertz. Okay, and also the voltage, the supply voltage for this device is in a very wide range. Okay, this device is working for 110 volts up to 240 volts. Okay, and it's very low power consuming. If you look over here and the brochure, you can see that the power consumption is around 250 watts. Okay, um, as I say before, this compact box has inside so powerful components. Okay, heat dissipation is a very important thing here. As a consequence, Typhoon HIL have include so many fans in this device, and as you can see over here, there is a fan located immediately to the right side of the power plug. Okay, what I will do now is I will go for the part that took me for a while, and I am loving this part. Okay, I will start from here. What you can see over here, that is a USB. You can see here the USB logo, and that is a USB terminal. In this case, we are talking about a high-speed terminal, USB 2.0. In this case, this is the Type B. At the moment, I will not make so much explanation about that, but we will be using that connector because here is where we connect the USB to the computer host in order to use the HIL control center software. Okay, then we have here a pair or couple of Ethernet connectors. Okay, you can see that that is our RG45 connector. The classical connector is for network cables, for the classical TCP/IP or many other communication protocol over the Ethernet cable. Okay, in the future we will be having a special video about this Ethernet port, because remember, my research group and myself, we are really interested on developing solution for wide area applications and control, and also we are interested on the digital substation IC61850. Okay, as a consequence, we will be running a special videos for this area. There is a micro SD that can be used for storage or file transfer. And here is one of my favorite parts. If you are working on protection, and especially wide area monitoring, control and protection, you are interested on time sampled values. Okay, if you are using PMU, you need synchronized measurements, and that is coming by using a proper time stamp. Okay, in this case, this device has two very interesting connectors over there. As you can see, there is one with the initials IRIGB. Okay, those are the initials for the Inter-Range Instrumentation Group Time Code. Okay, what is this? It's basically a format, a standard format that is used for transferring timing information. Okay, later we will have a video, because this communication port will be used for some testing, especially for phasor measurement units. Also, this unit, this HIL 604 is equipped with this golden terminal over here with the inscription PPS. PPS is the short for pulse per second, and that is for signals that basically produce a pulse per second. It's another mechanism, another way to create time stamp, time synchronization using your hardware in the loop. Okay, now I need to move to those very interesting connectors over here. There are two connectors over there, and you can see that there is an inscription
CAN1, CAN2, or CAN1 and CAN2. At the very beginning, I must recognize I'm not familiar with this communication port, but I was really surprised by then when I start to do some research, okay? First, this kind of connector received the name DB9. What is the reason for the name DB9? Well, the letter D is the most simple. As you can see, this look like a letter D that is rotated 90 degrees on the clockwise orientation. And the number 9 is because there are 9 connecting points over there, okay? That was the first surprise by myself. The name extremely simple. The numerical code is because the number of points. But then, what does mean CAN? Well, CAN is a communication protocol, and that communication protocol was developed specifically for the vehicle industry, okay? As you must be aware, modern electric cars, they have a very complicated electric system, and there is a network inside that inside the car. That network received the name CAN, and that is the short for Controller Area Network, okay? That is basically a protocol, robust protocol that has been used for vehicle bus, okay? This protocol is basically a digital protocol that can be used without a host computer, okay? I will not go in details at the moment. Probably in the future we will have a video if we find the application for our power system studies, okay? Finally, they are here to more communication ports. You must recognize because those ports are basically a connector that has been in the market for a while in telecommunications. Those ports, they are RS-232. RS-232 is a very well-known protocol for telecommunication starting in 1960s, and that is for serial communication and transmitting data, okay? As you must be aware, there are several relays that already have these RS-232 connectors, and we will be talking about those connectors more in the future, okay? Finally, I would like to close this workaround with those two connectors over there. Those are dedicated for the high-speed serial interface, okay? We are talking about here about PCIe. PCI, yes, is like the PCI that you have in your computer for sound cards or for video cards. It's basically a PCI. PCI is the short for peripheral components interconnect, okay? It's basically a protocol, high-speed protocol that is used for communications between hardware, okay? But this communication is basically a high speed that can reach 5 gigahertz, okay? In this case, we have here two PCI ports, RX and TX, and those ports are basically 8 lines each, okay? Well, and this is the back or the rear part of this HIL 604, okay? I believe we have worked around this device and we showed the main features of this extremely powerful, beautiful device for hardware in the loop and real-time simulations. It's time to close this video, and I am extremely happy to tell you that we cover very interesting topics here. We started with defining cyber physical system, and showing you how important cyber physical systems are in modern power systems. Modern power systems are cyber physical power systems. And in order to test and develop real-time solution for this kind of cyber physical systems, we need a very interesting and important technique that is called
hardware in the loop. And that's make me extremely happy in order to show you the product that we are talking today, the Typhoon HIL 604. The second part of this video, I present the HIL 604. I introduce few of the features, external features of this device. This device will be used many times in the future. There are many videos coming about this device, starting from creating a model from scratch using the software, the HIL control center, until we finally test relays in the loop using this hardware. Okay. Well, it's been a pleasure having all of you here. I hope you enjoyed this video. I hope you learned something from this video. Please feel free to drop an email if you have any question, and also any suggestion how to improve those videos. If you feel happy with those videos and would like to stay in touch, please subscribe to the YouTube video, and I will be uploading more and more videos. Thank you very much for now. That's all. Thank you.